Well, not much to look at on the surface map or outside with the drone. Just clear skies, and I just went ahead and let you guys look at some traffic and some of the scenes going on around town. Temperatures are near 80 here in Texas, and we've got a new Pacific system coming in from California and Nevada, but it's still located back over the Great Basin area. You can see in Nevada we've got the northwesterly winds gusting up to 20 to 30 knots, so that's a pretty clear sign that we've got polar air moving into that region. And down to the south, southerly winds at Vegas, Kingman, and Prescott. Going further out east, Texas is still under high pressure. We had a bit of a north wind when I was out there flying that drone, and the ridge axis, we can pretty much paint that out. There it is. Anywhere east of that, we got northerly flow. And on the west side of that, we've got the return flow starting up. And you can see that there's not much moisture yet. The highest dew point values I'm seeing are around Laredo there with 54, and everywhere else in Texas, 30s and 40s dew points, pretty much all the way up into Kansas. So we don't have a dry line just yet. Can't have the dry line without tropical moisture because that defines its westward limit. So we got the Great Plains under clear skies, and then we have this band of cirrus coming up from Southern California, and that's likely associated with a subtropical jet. We know that the surface front is right in that area right there. So in northern Nevada, there's some of the destabilization, giving us some cumulus fields on the mountains there. And if we go further back behind the front, looks like some thunderstorms, kind of rare for this area in northwestern Nevada. And we'll return to that when we go back to the northwest a little bit later. And there's the 300 millibar chart. This is up at 30,000 feet. Looks like we can pick out a little bit of a subtropical fetch right there. And then up to the north, we've got the main polar front jet itself from northwestern Nevada up to western Montana. So that right there is helping to support the thunderstorm activity in northwestern Nevada. For the southeastern U.S., we've got the cold front moving off the coast of North Carolina. And it looks like the tail end is around the Orlando, Tampa area. Out ahead of it, looks like we have a squall line, which has passed Miami, moving out towards the Bahamas there, and this all looks to be outflowish air. I'm not too sure that that's part of the actual polar air mass, because you can see the dew points back here. Even far behind the squall line, they're still up pretty high, and I think maybe the real transition to a polar air mass is up in the northern part of the state. And there's the satellite imagery. That appears to be the cold front right there, and out ahead of it, that's what I'm going with for the squall line. In fact, it looks like kind of a double squall line right there off the coast of the Carolinas. Up to the north, lots of cold air advection, and in fact, if you look closely, you can even see a bit of rotation. That may be barrier flow, because the Appalachians are right in that area. You can see that maybe there's a bit of vorticity on the lee side of those mountains right there. So, I don't know, there could be something like that going on. The surface chart does show it's quite cold. Lots of 40s and 50s in Tennessee, Kentucky, all the way up to Ohio. And there's probably enough reason to put a trough there with that little wind shift. You can see the winds come around from northwest to southwest just ahead of that. Yeah, it's still cold in the northeastern U.S. Looks like an occluded front across Pennsylvania. You can see the wind shift across that occluded front and the troughing associated with that. The main occlusion is up in eastern Michigan, up towards Lake Huron. And on the backside of that, we've got the cold northerly flow coming out of Canada and the Lake Superior area. And then at the very left side of the chart, Big Ridge, and that extends all the way up into western Ontario. And that pretty much comprises the cold air source, the south part of that high feeding cold air southward towards Louisiana, Mississippi, and Alabama, the north side of that ridge feeding the Great Lakes area. And there's a look at the satellite. Looks like a mid-level system right there across the Toledo area. That's drifting slowly eastward, and then the main baroclinic system is out to the east there. Not too sure where that warm front is, but just going by this, I would say it's probably across New Jersey, maybe, Long Island. Cold front definitely to the south of there. The water vapor imagery showing the high moisture content is out in the northeastern U.S. And back over Ohio, Indiana, and Michigan, closer to the occlusion, you can see that there's not as much moisture. Most of that is concentrated in the lower half of the troposphere. So we can't really make out that mid-level circulation very well unless we animate it. And so that's the main baroclinic shield right there, and then the cold conveyor belt and deformation zone up there in Ontario and Lake Michigan. And you can see why they call it a deformation zone. Look at how it's being stretched apart there. That is very cool. And this is a graphic that I found on the Slide Player website, which they pulled from somewhere. I don't know where, but this shows the idealized comet cloud appearance. This is the cold front here. There's the warm front. And then the occlusion is found back here. And this right here is the deformation zone that we were talking about. And just to give you the abbreviations here, CCB is the cold conveyor belt. The dry conveyor belt is here. That's that dry slot that we saw. And then the warm conveyor belt is out ahead of the system. And then we come full circle to the Pacific Northwest. Now we have a Pacific system moving across the northern Rockies. There it is right there in Alberta. Out ahead of that, pretty potent lee side trough. And then we've got downslope warming across much of Montana, where temperatures are as high as 75. Further down the front, we have another baroclinic low out around the Boise area with a cold front extending down into Nevada. We've got thunderstorms developing along that, and then another line of storms further west. And there we can see it on the radar animation. Can pick out that front pretty well there in northeast Nevada, and then out there in southeast Oregon, there's that other line of convection. There's a look at that satellite imagery. Cold front there in northeastern Nevada, and then the second line back here in southeast Oregon. And you can see some of those tops there, quite impressive. A little bit of texture on the top of those anvils. That's a look at the Boise radar. Pretty impressive line of convection there, and that's that storm that's producing some of the overshoot. You can see that they've got a slight bit of outflowish shape, suggesting cold downdrafts back behind there. There's certainly a lot of dry air aloft, and that's coming down to the surface in that cold pool. And there's SPC forecasting that marginal risk, covering the area out ahead of that line. Any mesoscale discussion? Yeah. So it looks like some instability and some shear, and they're looking for a few high base supercells. But it appears the activity is not going to be extensive enough to warrant a watch. And there's our weather chart for Europe. Looks like some Atlantic air. It's kind of weird saying Atlantic instead of Pacific. But yeah, Atlantic maritime air coming into France and Germany. Dew points in the 40s there, so it does have some moisture, and it is quite cool. Looks like the main baroclinic area, or I should say the warm sector, looks like that's in the Czech Republic, where we've got 60s. That's the warmest air in this latitude on the map. That's a good way of finding stuff in Europe. Look for the warmest air north of the Alps, and that'll kind of clue you in where the warm sector is. So that's what I've got there for Europe. And I figure we can also take a quick look at Asia. It is definitely warmed up in much of China. We're seeing a lot of 70 over 60, and that's very moist air. Not only is that from the South China Sea, the Pacific, but also due to evapotranspiration. We can see the semi-permanent high over the plateau, the Himalayan plateau there. And then up to the north, we can see a front coming down out of Russia. Looks like that's already occluding there. And north of that, we can see some pretty warm conditions, upper 60s. That's probably kind of on the warm side for this time of year. So we know that that is kind of a fresh conversion of tropical to polar air. So starting out with our forecast for tonight, ridge all the way from Lake Superior down to the western Gulf. The return flow is starting to set up in the Great Plains. It is on the dry side, and then up in the northwestern U.S., there comes our next weather system. For tomorrow night, we're starting to see the Gulf opening up down there on the South Texas coast. Southerly flow coming up all the way up into the Central Plains. Our Pacific system is staying well to the north, coming up into Minnesota, the Dakotas there, and the tail end front not making much progress south, a line from about Denver to Las Vegas. Now, something interesting does happen overnight, Friday night and Saturday. You can see that convective system coming together there around Cheyenne. That's due to that upslope that we've got going on in northern Colorado, bringing moisture up into that higher terrain. And you can see that MCS moving eastward overnight into Nebraska, and that's helping to lay down a cold pool, which is helping to push the front south into western Kansas. And you can see more storms start going up, and we get a kind of a bubble high. And then we end up with the frontal system. It's going to be running something like that right there. So frontal boundary, northern Oklahoma, up into southern Colorado. And that'll put Colorado under upslope flow. Looks like the dry line also may be starting to rear its head. I would expect that to be somewhere between Wichita Falls and Del Rio. And the NAM not breaking out any precip. Let's find out why. We'll take a look at a skew-t. We'll try Wichita Falls. And what I'm seeing here is some decent moisture. 71 there at the surface, tailing off only to mid-60s up at 4,000 feet. However, it does look like it is capped. I mean, we definitely have the instability. See right here, 3 to 4,000 Cape. That's pretty stout there. But convective inhibition is well over 150. And that wind shear does support rotating cells. So, yeah, the problem is it is capped. And looks like that cap base is at 850, extending up to 700 millibars. So to overcome that cap, we definitely need some help coming in from the west, like an upper level system. So our convective outlooks over the weekend, going into the weekend, just mostly focusing on upslope stuff. There's Friday right there. And then Saturday, yep, more upslope stuff. So we're probably not going to have much going on for the remainder of this week, but I think once we get back into the saddle again for next week, we'll probably have some severe weather to look at. And for our viewer mail, got one from Daniel Park here. Daniel's from Australia there. Looks like Brisbane. And he's mentioning they're getting a little bit of severe weather right now. I appreciate the comments. And thanks for watching the webcast. And I also have this picture from one of our viewers, Andrew Walters. This email went to our address for orders instead of the one for the weathercast, so I didn't get it until now. But this is for April 24th, and it shows some of the convection near Paris, Texas. And Andrew says he's an avid reader of the Blue Book, severe weather forecasting, and I appreciate the image. And if for some reason you've tried to contact us and haven't received a reply, or if you've sent in Patreon support and haven't seen your name on the titles, I can promise you it's just an oversight. I tend to be a little bit disorganized with email, but I'm certainly trying here, and after this is all uploaded. I'm going to work on that some more. If that's the case, just try dropping me another email. You can also email servicedesk@weathergraphics.com, and one of us should be back to you very shortly. Anyway, that's all I got for this evening. Thank you for watching, and we will see you tomorrow. Bye-bye.